Hello, I wanted to discuss the profit, revenue, costs equations coming up in section 4.7 and specifically look at the problems given in the applications since a lot of students tended to struggle with this unit, and it is important to know how the algebra happens in these equations because you will be seeing it on your upcoming tests. So looking at our application homework for section 4.7, they gave us the price equation representing the number of coffee makers that we can make and sell. So the price equation was given to us. Previously in our textbook, they didn't give us this price equation. They gave us 2 points or 2 values in a table relating how many items we could sell for earrings and then what the price we could sell for those earrings would be. So here, a lot of our work has been taken care of because they told us our price equation. So that's already taken care of. If they hadn't told us the price equation, then we would need to have found it. So the price equation is linearly related to the number of items. So we think of it as lowercase p equals mx plus b. And so if they hadn't told us this equation, we would have to have gone through and calculated the slope first. If they'd given us 2 values listed as points or 2 values in a table, and then secondly solved for the b values. So if you don't know how to do that, how to solve for m and find the b, then that's definitely a topic to review either in ALEKS or also go back and look at the example that we did together in class to find the profit equation. So here, our our price equation is given. It's this negative 0.27x plus 51. And what we want in number 1 is the revenue. So we need to know that revenue is found by taking the number of items we sell, in this case they're coffee makers, which is x, and multiplying it by the price equation. So the shorthand way that we write that is capital R, which represents your revenue, is x times p. And this lowercase p is that price equation that we saw previously. So if I want to go ahead and multiply that, I still want to write down my r so we know which equation we're talking about. And instead of p, I'm going to replace that with the right-hand side of my equation. That's called substitution. We can substitute one value or variable for what it's equivalent to. So p is equivalent to the negative 0.27x plus 51. And I've essentially found my revenue equation, but it's not simplified. And we definitely want to simplify all of our equations down as simple as they can go to make them easier to use later. So what I need to do then is actually perform this multiplication, which we call distribution, right? I distribute the multiplication of x to the first term in my parentheses, which is the negative 0.27. My x multiplies with a second x, and so we write that as x to the power of 2, or x squared. And then I also need to distribute the multiplication to the 51. So that would be plus 51, and since there wasn't an x before, it's just a single x now written. So that's as simplified as we can make it. That is the revenue equation that we wanted. In 2, they wanted us to look at our cost equation. So they told us the cost equation, and this one's a little bit more complicated than the one we saw in the textbook. So our costs are not actually linear here, which can happen. Sometimes if you have a more complicated situation, your costs may not be linearly related. There's also the option, just to note, kind of like what we did in the textbook, sometimes, and most of the time, your cost equation is linear. So you have some sort of variable costs, like how much it costs for me to produce my item, right? All the materials and all that. And then our B, which is the fixed costs. And those would be things like paying my employees, paying my rent, paying my insurances, things that won't change depending upon how many items I sell. So here we have a more complicated situation for a coffee maker because there's probably more going on. And they want us to write an equation describing the profit. So here we need to know that our profit is always found by taking the revenue, or how much money you earn from selling your items, and subtracting away your costs associated with making that item. So again, we're going to use substitution. Instead of R, I'm going to substitute the right-hand side that has everything in terms of X, because that's what we're interested in, is how many items do I need to sell to get maybe a desired profit, right, or a desired result. So I replaced R with the right-hand side of its equation, and then we'll subtract C. And so again, I'm going to substitute the right-hand side instead of C. So negative 0.12 x squared plus 12x plus 120. So I've essentially written my equation, but it's not simplified. We want to simplify it down and make it easier to use. So here, my first set of parentheses aren't really doing anything. I just put them there as a placeholder. They're not multiplying anything. They're not doing anything, so I can just kind of get rid of them. However, my second set of parentheses are doing something. They're helping me realize I need to subtract all of the terms from the cost equation, and that's important. Some people even like to think of this as a multiplier of like a -1 that we distribute through to all of our terms. So the key part is that subtraction or multiplication -1, however you want to think of it, needs to apply to all my terms in the second set of parentheses. So for the 0.12x squared, I have a negative applying with another negative. So I have double negatives, so that becomes a plus sign. The 12x was positive, but again, I have the negative sign applying. So a single negative will keep negative. And also with the 720, I have a positive with a negative getting applied, so a single negative remains negative. So I've performed the subtraction of all my terms, but I'm not done because I do have like terms that we can go ahead and add up and combine. So I'm actually going to kind of show that line of work kind of underneath here. So I look through for all my like terms. Like terms need to have the same variable raised to the same power. So if I go through and look, I have negative 0.27x squared and 0.12x squared. So if I go ahead and add those up, it's going to be negative 0.15x squared. Then I look through for all my x's. So I have a 51x and a negative 12x. So those go ahead and add up to 39x. And then last but not least, the only thing left over is my negative 720, that what we call our constant term. And we'll carry that on down. So that is your simplified profit equation. And that's really useful because now if I want to plug in a certain number of coffee makers, like in problems 3 and 4, I can do that really easily. I just replace X for how many coffee makers I'm interested in. So for 3, we're looking at 20 coffee makers. So again, we're using that idea of substitution, that I can replace a variable with what it's supposed to be equivalent to. So in my wonderful profit equation, I'm going to replace X with 20. And then this would be something, because of the decimals and because of all the multiple operations, I would just type that directly into my calculator, kind of like I see it, and then see what results comes out. So that one, if I type it all in, I get 0. So what does that mean? It means when I sell 20 coffee makers, the profit I earn is 0. And that seems maybe not ideal, but that's actually really important because that 0 means that's when I start actually earning money. If we think about what that graph looks like that we talked about in class, our graph has that kind of U shape to it. So we're looking at this point right here. That's your 20. We're looking at when do we finally start making money, and we've essentially paid for all of our costs for our business. So maybe you guys have heard this in maybe economics class before or in other places, but this is what we call the break-even point. The break-even point is defined as when your costs and your profit are equivalent, right? When you're not losing money for your business, but you're also not earning a profit either. So 20 is kind of the magical number where if I sell past 20, I'm going to start making some money. In 4, they want us to, again, look at our profit equation and calculate it now for 100 and 200 coffee makers. So taking my same equation, replacing X first with 100, and then we'll also replace it with 200. So first, if I replace it with 100, and again, just type it in kind of like you see it into your calculator, that would get me an end result of $1,680. So that would be my profit for selling those 100 coffee makers. And then we would do the same thing for 200. If I put in 200 into my profit equation and seeing what comes out. So for 200, the profit we earn is $1,080. Now that may seem a little bit confusing because you would think if you sold 200 coffee makers, you'd be making even more money than you did for 100. But the truth is we're not. We're making less money. And that goes back to the shape of our relationship, that our profit equation has an x squared in it. So that has that upward or upside down U shape. So that means for the 100 per se, maybe I'm right there, right? I'm making a good profit. But then for 200, I've gone past kind of my maximal or ideal profit point. And now I'm making too many items that my costs are eating up my profits. So that's why that kind of worked out that way. 5, I told you guys, was an extra credit problem. So you didn't have to do problem 5, and problem 5 will not be something that you would see on the exam, but it's definitely neat to know where that highest profit value is going to happen. And so you could do trial and error and plugging in different X values into the profit equation and seeing which one gives you the highest profit output. But really what we're trying to find on our graph is that highest point, that maximum profit point at the very top. So that's really easy to do in Graphing Calculator, and I think I actually showed your class how to do that. So in a Graphing Calculator, if I go to the y equals and type in my profit equation, and then I had to play with my window sum to make sure that it graphed the whole graph, but those were the dimensions of my window, going up to an x value of 300 and going up to a y value of 2000. You can see my graph. There's our upside down U shape. And I'm looking at the highest point. I want to find the highest point. So I can kind of eyeball it on my graph, but your Graphing Calculator will find it exactly for you. You go into this second Calculate menu and then go down to the maximum option. And you have to give it some information. So you move your cursor to the left. So it's definitely on the left of that highest point. You hit enter. And then it's going to ask for the right bound. So you move your cursor to the right until it's definitely to the right of that highest value. You hit enter. And then the guess option is just nice to give it a guess so that it can calculate things a little bit more quickly. So there's my guess. And so there was a little bit of approximation we can see. It's not exactly 130 units, which it should be, but it would round to 130 anyway. And that's just part of the points I selected. If I'm off a little bit on my points, then the calculator will be a little bit off too. But we can see that our X value, which is the number of coffee makers, is about 130. And then the Y, or the output, which is our profit, the highest profit I can achieve is $1,815. So here we're really interested in the number of units. So that was the 130 coffee makers. And more than profit, they want to know the price that we charge those coffee makers to be. So at the very, very start of this whole page, they gave you a price equation of negative 0.27x plus 51. And instead of x, we can replace that with the 130 and then calculate this. So the price, when you calculate it for 130, is $15.90. So if I can charge my coffee makers at $15.90, then I'm setting myself up to get that maximum profit. So again, if you are struggling with these different price, revenue, cost, profit equations, it's definitely worthwhile to go back and review them in the textbook and then maybe even work on the ALEKS topics that help you in calculating the algebra of subtracting, say, your cost equation and then distributing the x within your revenue equation.